Hi everyone. In this video, I am going to show you how to graph a piecewise defined function. Okay. However, this piecewise, okay, is not a function, and I'm going to explain it after. Okay. So let's start. Let's start with the graphing. So again, let me use different color for the domain, the restriction domain. So the first function is x minus 3. So the linear function x minus 3 can only be graphed or seen if the x value are less or equal to -1. So I'm going to look on the x-axis, okay? What are the x values that are less or equal to -1? So am I going to highlight all the number on the left side of -1 or on the right side of -1? Remember, the domain restriction for the first function is for all the x value needs to be less than or equal to -1. And for that reason, so I'm going to shade all the number on the left side. Okay, I'm shading everything because why? So those number on the left represent numbers that are less than -1. So let's say, let's say -5. So -5 is less than -1. Why? Because it's far away from 0. Okay, the farther you go to the left, the less the number is. Okay, so let me highlight. So this is the domain restriction for the first function. So how am I going to graph? So remember, so we want to graph the function, the linear function. Let me write it below. Y equal x minus 3. So what is the number for the slope m? Okay, m represents the slope. Okay, the slope is a number in front of x. Okay, so what number do you see is in front of x? Can it be 0 or 1? So it cannot be 0, so it has to be 1. So the number in front of x is 1. So how do we turn 1 as a fraction? You draw a line and you write 1 below. Because so now this is the 1 represents the rise and the 1 below represents the run. Because the 1 is positive, so I'm going to rise 1 unit. And then because the run is positive 1, so I'm going to move to the right 1. Okay, and by where are we going to start? We always start at the y-intercept, the number added or subtracted. Okay, so what is a constant being added or subtracted? It's -3. That's the y-intercept. And mathematicians have agreed to label y-intercept or to define y-intercept as the vector variable b. So b equals -3. So what does it mean? So I'm going to start at the y, look on the y-axis to identify -3, and then start from there. Okay, so to build a line, and then from the y value of -3, so I'm going to go up 1 and move to the right. Okay, that's what I'm going to do to build a line. And remember, you want to follow the restrictions. So what the domain restriction is, the x value must be less or equal to -1. So I'm going to draw a vertical line, like a visual reminder, not to ever cross that line. So I cannot, so the domain, okay, cannot cross over the line of x. The line of the function cannot cross the line, or can be on the line, but it cannot cross over the line for the line of x equal -1. So I'm going to shade this region right here so you can visually see, okay, where the line that you're going to graph must remain or be seen only. So we cannot pass that line of x equal -1. And that's also I'm shading the region on the left. Why? So you can remind yourself not to cross over this line, right? So let's start. Where do we start again? Always start at the y-intercept, which is -3. So I am going to locate -3 on the y-axis, never on the x-axis, on the y. That's what we call the y-intercept. And -3 is right here. So I'm just building my line. So, but remember, my line must be in a shaded region, the shaded yellow region. So at -3, I'm going to go up 1 and move to the right 1. Up 1 and move to the right 1. So I hope you see that there's something off here, right? I told you the line can only be seen on the side for all the x value less than -1. So my line must be graphed only right here. So I cannot continue forward. So what must I do then? Okay, so you go back to the y-intercept and you're going to move backward. Okay, what do I mean by move backwards? So I want to draw the line on the other side. So what am I going to do? You're going to go down. So I'm going to do the opposite of the slope. Here, the direction for the slope, for the rise and the run. Instead of going up, I'm going to do the opposite. I'm going to go down one. And instead of going to the right, I'm going to move to the left one. Okay, why? I'm using the other side of the line, and I'm going to continue the same patterns. Then one to the left one, 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 then one to the left one. So I have enough other pair. I like to see as many other pair as you can. Don't just do 2 or 3. Do as many as you can. So now I don't need the other pair on the right side of -1. So I'm going to erase those other pair. Okay. Now x equals -1. Okay. They say the x value can be -1. So on the line of the function, when x equals -1 is going to be a full dot right here. Okay. So I'm making a very full dot or closed dot because of a line under inequality, the x value can be the number -1. Okay. If they didn't have a line under inequality, it would have been an open dot. Okay. Oh. So now you're going to connect the dot with your ruler, and now you're going to make sure you include the arrows on the left side of the line, but you cannot include the arrows on the right side because of the domain restriction. Okay, the line can only be seen for x value less than -1. So on the left side of -1. Okay, so we are done graphing the first equation, the first linear function. Next, you want to graph the second linear function. Okay, where are you going to graph this line of 1/4 of x plus 1? You always want to shade it on the right. So you want the x value greater or equal to -1. So this is -1. So the number that are greater or equal to -1 are going to be on the right side of -1. So that's why I'm shading all the number on the right side of -1. So this line can only be graphed, can only be seen right here. Okay. So let me use another color, and we're going to shade that region as a visual reminder not to cross over, not to to remain in that location, in that region on the graph. Okay, so I hope it makes sense. So now I'm going to give you time. Okay, how would you build a line? Okay, what is the slope, and what is the direction for the slope? Okay, and what is the y-intercept? Okay, and where would you start? Okay, so we know that the slope is a number in front of x, which is 1/4. Okay, and because 1 is positive, you're going to rise 1 unit. And because the run is positive as well, you're going to move to the right. Okay, if it was negative, you move to the left. Okay? So because 4 is positive, you move to the right. And always, where do we start? We will always want to start at the y-intercept. And the y-intercept is +1. Okay, so now I have all this information, so now I can build my line. And I recommend that for graphing, use a graph paper to be accurate and precise as you build a line. Okay, so that's my recommendation. Okay, so where do we start again? We start at the y-intercept. So I'm going to look on the y-axis and identify the 1, and right is 1 here, is right here. So I'm going to place a dot right there. Okay, then what do? So I'm going to go up 1 and move to the up 1, move to the right 4 times. Okay, and then I place my order there. Then you start at the y-intercept 1, you go up 1, and you move to the right 4. You continue up 1, and you move to the right 4 times. Up 1, and you move to the right 4 times. Okay, I think I cannot continue further, but I have enough. Okay, so now I can build the line. As you build a line, okay, so let's use my ruler to connect. Okay, so what I want you to see here, if you do this, you're not correct. Okay, because you need to continue the line until you reach out the line for x equals -1. So I am just going to use my ruler and make sure I follow the path here. So this is supposed to be now correct. Then my line reached the line of x equal -1. So at x equal -1, because I have, sorry. So now because at x equal -1, I also have an equal sign. So the x value can also be equal to, the x value can also be equal to -1. So on the line on the linear function is going to be a full dot. Why? Because the x value can also be -1. Okay. So now I am done. So if you want, you can erase the visual reminder line because you don't need that anymore. And you're done graphing our piecewise defined function. Okay. However, like I explained before, this cannot be this is not a function. Okay. I hope you can tell me why it's not a function. Okay. Why is it not a function? Okay. Okay. So I explained below that this piecewise is not a function. Why? Because for the same x value. So you see that for x equal -1, so we have two different y values. So I'm going to approximate this one to be, let's say, 0.75. So we see that when x equal -1, the y value is also 0.75, as well as what? -4. Okay. So for that reason, okay, this piecewise is not a function. This piecewise relation is not a function. Why? For the same x value, you have two different outputs. Okay, and remember, so an illustration of this is for your age, you cannot have two different heights, let's say, right? So that's why, or for your location as a person, you cannot be, let's say, at your place and also at school at the same time. Okay, so it's not possible. That's why we say that. So basically, for the same x value, you have two different outputs, two different y value. So this is not the function. Okay, so remember this. I hope my video is helpful. So have a wonderful day and see you into the next video. Bye bye.